Okay, I have the Chem 1 final exam study guide here. You can find this on Moodle right near where you click this video. You've probably already seen it. I'm going to talk you through the study guide and make sure that you are well informed of what's to come on your final. A few things to remember. Make sure you have any late work you want me to consider, any lab makeups, anything that you want me to consider for accepting late needs to be in by the due date specified on Moodle, so most likely that's on Friday. So please don't delay with that. If it comes in after my final acceptance time, then I'm not going to take it. I have too much of it to look at to get everything done on time. Aside from that, the final, like I've said, will be on Chem 101. So make sure your device is ready to go, it's charged, all that good stuff. And it will be just like the test we did just before Thanksgiving in class. Okay, the exam will be open book. However, in order to finish on time, you need to know how to work the problems efficiently. Just because it's open book does not mean that you don't need to prepare. So you really need to study, and if you're going to finish it on time and not be 100% stressed out. So working through practice assignment on Chem 101, which is posted and for extra credit, going through the study guide will help ensure that you're prepared for the exam. It may be helpful to mark your book and workbook with sticky notes to help you find certain topics that you need to reference quickly. I mean, for any open book test you ever do, this is a good one. It might be helpful to have note cards for each topic that tell you what pages to go to, a paper, something, or take your workbook or your textbook or both and write on a post-it note, stoichiometry, and then stick that in the page where you find the stoichiometry example or something like that. So that's what I did when I was a student with open book tests, and I found that helped me spend less time hunting around in a book for something that I probably know that I was going to need. Okay, the test will be cumulative. That means if we learned it in class this semester, so in class, on homework, in assigned videos, or in assigned readings, it may be found on the test. So that means anything we did this semester is fair game and you need to know it all. With an open book test, it is best to use your workbook to confirm your answers rather than to hunt down answers to each problem. So again, that just means you need to prepare. You're not going to do well even though it's open book if you come into this test without having prepared at all. So first things, units of measurement, prefixes, and conversions. You can find that on workbook pages 1 and 2. Sig figs, refresh your memory. I had a handout in class for those. You can find that on Moodle. Textbook page 17. That's textbook, not workbook, page 17. Also has a summary of that. The makeup of atoms, ions, and isotopes. So that would include things like protons and neutrons and electrons and their charges, quantities of protons, like if the atomic number is 30, that means we have 30 protons and 30 electrons, unless it's an ion. That general stuff. The periodic table. Workbook page 28 has the periodic table. Also, you have the periodic table that I printed out, I think, on green paper and gave to you in class that you labeled with all kinds of things. Have that with you. That will save you a lot of time hunting around for things. So make sure you have that green periodic table handy. Know the general layout of it. So what is a period? What's a group? Common group names, they're the halogens, alkali metals, the noble gases, etc. Where the metals, nonmetals, and metalloids are, those types of things. Know trends of the periodic table. So going across a period, atomic radius decreases. Going across a period, electronegativity increases. Those types of things. Again, those should be labeled on your periodic table. Know how to determine ion charge based on location. Also labeled on your green periodic table. So, for instance, calcium is in column 2, therefore its charge will be positive 2. Fluorine is in column 17, one column to the left of the noble gases, so its charge is -1. Know how to determine the number of valence electrons based on location. Remember that goes, like carbon is in column 14, it has 4 valence electrons. Column nitrogen is in column 15, it has 5 valence electrons. I think we also label that on your periodic table. Nomenclature. There are handouts on that. Workbook section 3-1, which starts on page 32. Your textbook, there are lots of resources for nomenclature. Ionic nomenclature of main group elements. So remember, main group are the kind of the higher parts in the periodic table, columns 1 and 2, and then columns 13 through 18. The transition metals are not main group. Remember, with ionic nomenclature, we don't use mono, di, tri, tetra, and so on. When we have ionic nomenclature of transition metals, we're going to use a Roman numeral to designate the charge or oxidation number of the metal. So remember, copper can form a +1 or +2 ion. So we have copper, parenthesis, Roman numeral 1 to show the charge for copper. So I'll write that on here. Copper 1 equals that. So remember to do that because it will be counted wrong if it does not have that. You need to know polyatomic ions and their names, their formulas, and their charges. Again, there's a handout on that you can reference, but like I've told you all semester, you just need to know them. It'll make your life a lot simpler. Covalent molecular nomenclature, that's pretty simple so long as you know your prefixes, mono, di, tri, tetra, penta, so on. Remember, covalent and molecular nomenclature, covalent and molecular mean the same thing, so those aren't two different things. Covalent and molecular are the same thing. This is for nonmetals only, so remember that zigzag line of the metalloids. If it's to the upper right of that, you're going to use the mono, di, tri, and so on. Number 6, moles and molar mass. Check out workbook page 44 on that. Know Avogadro's number and how to use it. 6.022 times 10 to the 23rd. So know how to use that in stoichiometry calculations and so on. Know what a mole is and how it relates to various aspects of chemistry. For instance, a mole of carbon atoms weighs 12.01 grams. You find that on the periodic table, 12.01. And that if you have a mole of sodium atoms, you have 6.02 times 10 to the 23rd sodium atoms. So nothing crazy, but remember to refresh your memory of what a mole is. Stoichiometry, this is probably the part where most of you will probably want to spend the most of your time practicing. So first off, know how to write chemical equations. That includes precipitation. In other words, you need to know your solubility rules. So that's another thing you'll probably want to mark in your book is your solubility rules. Know how to balance the equations once you have it written. Know how to perform stoichiometric calculations, such as a limiting reactant problem, percent yield problem, those types of things. Know how to determine the molarity of a solution after a dilution. That isn't hard, so long as you remember how to do it. That's M1V2. M1V1 equals M2V2. Remember that molarity equals moles over liters. Know how to do a titration calculation. Remember, titration calculations, you're going to have to use the molarity, this part of the molarity, as one of your conversion factors. Oxidation and reduction was another type of reaction. I'm not going to make you balance a redox reaction, mostly because they take a long time. But I do want you to know how to determine what is oxidized or reduced, as well as the oxidation numbers. Workbook page 94 will help you remember that Leo says Gur. If we lose electrons, we are oxidized. If we gain electrons, we're reduced. I think oil rig is another one. Oxidation is loss of electrons. Reduction is gain of electrons. Thermochemistry and calorimetry, that's workbook page 109, it's in your textbook also. I'm going to have you do a calorimetry problem, and I want you to understand Hess's law, but again, these are pretty time consuming, so there's not going to be a lot of these on your test. It would be helpful for you to have note of where to find them in your workbook and your textbook for worked out examples and constants and things like that. Electron configuration, you need to be able to write electron configurations in long form and the noble gas short form. So you'll want to have either committed to memory or your diagram that goes 1s2, 2s2, so on. I want you to be able to draw orbital diagrams. So orbital diagram is the thing that looks like this. Hunt's rule means that that's the school bus seat rule, we fill in the spots one by one and only double them up once we're out of space. Lewis dot structures, that would be like carbon has 4 valence electrons, so it has 4 dots around it. If we had nitrogen, it has 5, so one of them would be doubled up. So that's a Lewis dot structure. Lewis structures, you need to be able to draw Lewis structures of small compounds. Those would be things like what we did in class. We've done ammonia, we've done carbon dioxide. So ammonia would be like this. So know how to draw those properly. Make sure you have your lone pairs and all that taken care of. Determine the geometries and bond angles using VSEPR, valence shell electron pair repulsion. You will want to mark page 202 in your workbook. So even right now, hit pause, go to your workbook, and mark that, because that is the page that has all those geometries in it. So rather than hunting around for that, I'm telling you now, you will need it, so just mark it. Know how to determine if a molecule is polar or not polar. So that is in your workbook shortly after the Lewis structures. And then finally, gas laws. The best way to have this is that gas laws note sheet that I gave you in class. It's also on Moodle if you've lost yours. But having that handy will save you a lot of time. You have all of your unit conversions on there for pressures. You have constants for R. You have all of the gas law equations you need, except Dalton's law of partial pressures. So you'll want to put that on there. Know the basics of the kinetic molecular theory of gases. There are YouTube videos about that, but also your workbook and your textbook outline that really well. And then be able to use the gas law equations to solve the problems. Lastly, familiarize with your textbook and how to use the index and find information quickly. The test format will be similar to the last test we took, however, it will be longer. It's your final. You'll have an hour and 50 minutes to complete it. So make sure that you are ready to start it on time. Check the email I sent you all on, I believe it was Tuesday, with information for the end of the semester, so that you aren't confused about when your final exam is. Aside from that, if you have any questions, please let me know. I will be in and out over the weekend, so I may not be quick to respond, but I will try to check my email throughout the weekend and get back to you with any questions that you have. Other than that, that's what you can expect for your final exam. There shouldn't be anything that is surprising on there. I'm not planning to give you any big shocking problems. It should all be familiar stuff that we've done for months already. All right, thank you very much. It has been great having you all in class, and I'm looking forward to seeing you again in Gen Chem 2. And if you haven't done your course evaluation survey, please look for the email from Sandy Hebert with directions for doing that, and make sure to put in that evaluation by the deadline time. All right, have a good day, good luck studying, and good luck on your final.